example, we would have something like 6 times the quantity x plus 4. And the distributive property says that we multiply the quantity outside times both of the quantities inside, and we keep that sign. So 6 times x is 6x. We keep that plus sign. 6 times 4 is 24. Now, can we add those together? No, they are not like terms. So our answer is just 6x plus 24. All right? All right. Okay. Let's do some practice. We're literally just going to go through this very quickly. I'm going to have you write it in your notes. Do the math, and then we'll move on to the next one. So it's just going to be kind of a quick review. Everybody should be writing, so everyone should be doing each of these to practice. Some of them are a little more tricky than others. Some of them will be super simple. But I want you to practice each one with me so that when we do the homework practice, you've practiced how to do these. All right, 4 times the quantity, 7 plus y. Tate, tell me what to do.
Yeah, so do 4 times 7, which is 28.
Good.
And then you do 4 times y, which is just 4y.
Good.
And then you put down the addition sign.
Very good.
And you can't add them because they're like.
Very good. We can't add them because they're like terms. So 4 times 7 is 28. We bring down the plus sign. And 4 times y is 4y. Okay? We cannot combine these. They're not like terms. So our answer is just 28 plus 4y. Leave it like that. We're done. Let's do another one. Try this one in your notes. 8 times the quantity, x plus 7. 8 times the quantity, x plus 7. Hudson, what'd you get?
I got 28 plus 4 x.
For this one, though. For this one. 8x plus 7. Miles, what'd you get?
8x plus 56.
Very good. AX, we brought down the plus. 8 times 7 is 56. 8x plus 56. Good. With me so far? Okay. Let's do another one. 3 times the quantity, x plus 4. Bless you. 3 times the quantity, x plus 4. Write this in your notes. Do the math. Distribute in that 3 to both terms, which means we are multiplying. And make sure you multiply the 3 into both of the terms inside. Modiba, what'd you get?
3x plus 4.
3x plus?
Oh, wait, I mean 12.
Plus 12. Very good. 3x plus 12. In order, so this looks a little bit different because we have our number on the other side. We can just rearrange it. What property says we can rearrange it? Yes. Owen, what'd you say?
I said commutative.
That is correct. The commutative property says we can multiply in any order. So we could also say 4 times the quantity y plus 5, because it is okay to multiply in any order. Luke, what'd you get?
I got 4y.
Yep.
Plus 20.
Very good. 4y. Brought down the plus. 4 times 5 is 20. Very good. 4y plus 20. Could you also say 20 plus 4y?
Yeah.
Yes, because of commutative property of addition. Yep. Yeah. Order. You can add in any order. All right, let's do another one. All right, fractions will show up. That's fine. We know how to multiply with fractions. So go ahead and write this one. 1/2 times the quantity, 6y minus 2. Couple things to notice here. First of all, we'll be multiplying fractions. Second of all, notice our sign in the middle is subtraction. So we need to make sure we bring down a subtraction sign in between rather than an addition sign. So we're going to multiply 1/2 into both. What is 1/2 times 6/1? Tate, what'd you get?
3.
Good. Okay, so 3y. And then when we do 1/2 times 2/1, what do we get? 1. So minus, make sure we bring that minus sign down, -1. So our answer is 3y minus 1 once we have distributed in the 1/2. Okay, what about when we have something like this? 3 terms inside our parentheses. Go ahead and write this in your notes and solve. There are 2 different ways we can do this. You can do either way you want, as long as it is correct. 9 times the quantity 6 plus x plus 2. Hudson, what'd you do?
So first I did 2 plus 6.
Okay, good. So first, he combined the like terms inside the parentheses. So 9 times the quantity 8 plus x. Good. And then what'd you do, Hudson?
And then I did 9 times 8.
Good.
72. And then plus 9x.
Perfect. 72 plus 9x. Now, the other way you could do this would be to do what? Did anyone do it the other way? Kennedy?
Do 9 times all the
Yes.
terms in the parentheses.
Good. So the other way to do this would be to just distribute the 9 to every term, right? So then we get 9 times 6 is 54. 9 times x, so plus 9x, plus 9 times 2 is 18. And then we can combine our like terms. And we end up with the same answer, 72 plus 9x. So either way, you get the same answer. There's just 2 different ways to do it, okay? You can do whichever way makes sense to you, whichever way you like better. Try this one. 3 times the quantity, d minus 11. Distribute. Modibo, what'd you get?
3d minus 3d.
Yep, 3d minus, what is it?
Okay, 3d minus 33.
Very good. Minus 33. Good, and he remembered that this was a subtraction sign, so we put that subtraction sign in the middle. Very good. All right, let's do a couple more. Try this one. Try this one. Write it out in your notes and distribute. 7 times the quantity 2 plus 6 minus 4x. Kennedy, what'd you do?
I added 6 plus 2.
Okay,
And then, so I put the 8, and then I did 7 times 8 is 56.
good.
And then 7 times 4x is 28x.
Good. Perfect. Okay, so she combined the like terms first inside the parentheses. We can add those first, and then we can distribute. So 7 times 8 is 56. We bring down our minus sign, and 7 times 4 gives us 28x. Good? Are you remembering this?
Yes.
Okay. Let's try a couple more. Now this is where it gets a little bit more. We got to think a little bit more, so pay attention. Okay. Remember, we can only combine like terms if they have the same variable taken to the same power. So give me one set of like terms in this expression. Tate?
3x and 2x.
3x and 2x. Okay, if we combine those terms, remember we add the coefficients. So what is 3x plus 2x? 5x. Very good. Okay, and then remember our constants are always also like terms. 9 minus 5. What is 9 minus 5? 4. So then my simplified expression is 5x plus 4. All right, moving on. Okay, this is where we started to get confused, I feel like, on the last homework. So I don't want to do a few of these that have sort of a few different things going on. 7x plus 2 times the quantity x minus 5. What is the first thing that we should do here? In order to simplify, what should we do? What do you think, Colin? Give it a guess. Okay, what do you think, Tate?
You can do 2 plus 5 or 2 minus 5.
What should we do? Ooh, this is good. I'm glad we're doing. What do you think we should do?
7x plus x.
What should we do?
7x plus x.
Not 7x plus x. What do we need to do first?
7x times.
No. Okay, I'm going to tell you what we're going to do. Notice this little situation here. What does this look like?
Oh, 2.
We need to distribute the 2. Do you see how that is 2 times the quantity, x minus 5? So before we do anything else, we've got to be able to distribute so that we can combine like terms. I'm going to bring my 7x down, because that we didn't do anything to, and then I'm going to do my distributing. 2 times x is, Roger?
2x.
2x.
And then 2 times 5 is 10.
Good. And what sign are we going to put in?
Subtraction.
Good. So 2x minus 2 times 5 is 10. Now that we've distributed and gotten rid of those parentheses, we can combine like terms. Colin, what would you do? Good. Perfect. So 9x. 7x plus 2x is 9x. Minus 10, because that's not a like term. Ooh, goodness. So our simplified expression is 9x minus 10. When you see the parentheses, you have to distribute before you can combine any like terms. Okay, let's try to do another one like this. All right, try this one. 3 times the quantity b plus 5 plus b plus 2. So here's the situation. We've got some parentheses. Before we can do any combining like terms, what must I do first? What must I do first? Tate?
You have to do 3 times b, which is 3b, and 3
Good.
times 5, which is 15.
Very good. So you have to distribute in the 3. 3 times b is 3b plus 3 times 5 is 15. And then we're just going to bring everything else down. Plus b plus 2. Those aren't in parentheses, so they're no problem. We just bring them down and then combine like terms. Give me one set of like terms. Colin?
3b and b.
Good. 3b and b. What's the coefficient of b?
1.
1. Good. Remember that. There's that imaginary 1. So when we combine these, 3b plus b is what? 4b. Good. And my other like terms are 15 and 2. My constants are like terms. So I get what? Kenny?
4b plus 17.
Good. 4b plus 17. Okay? Let's see if I have any more. Okay, let's do this one, just because. This is not difficult, so don't let it freak you out. Just follow the same rules. Hudson, what would you do?
Okay, so you do 7p
Good.
plus 7q
Good.
plus 62.
Good. Notice how he multiplied the 7 to every term inside the parentheses. 7p plus 7q plus 63. Can I combine any of those terms? No. They're all different variables. P, we can't combine that with q because they're different letters. And 63 is a constant. So, how many terms do I have in my answer? 3 terms. That's okay. Okay? All right, one more. One more. Let's try this one. Okay, I want you to write first before you put your hand up. Write first and then put your hand up. Okay, we've got a couple sets of parentheses here. So we are going to have to distribute before we can start combining any like terms. All right, what'd you get for the first set? 6 times the quantity x plus 1. Roger, what'd you get?
I got 6x plus 6.
Perfect. 6x plus 6, and then we're going to add our second set of distribution. What'd you get, Luke?
I got 6.
Good.
Minus 3x.
Perfect. 6 minus 3x. From here, now that we've gotten rid of all the parentheses, we can combine like terms. So let's indicate what our like terms are. What's one set of like terms? Miles. 6 and 6. What's 6 plus 6? 12. Okay, and then our other set of like terms is what? This one's a little trickier. Kennedy, what do you think?
6x and 3x.
Good. 6x and 3x. Make sure we remember that minus sign goes with the 3x. So when we combine them, we do 6x minus 3x. And what does that give us? 3x. So 12 plus 3x. That is our simplified expression. So always distribute first so that you get rid of the parentheses and then you can combine like terms. Yes, sir.